Hello and welcome to lesson 8.4. Today we're going to look at more properties of multiplying exponents, and specifically we're going to look at what we call a power to a power and the product to a power. The first thing we're going to look at is called a power to a power, and just as the name indicates, this means we're going to be taking a power and raising that power to another power. So you can have a visual of this. If you look right here at the example, we have 5 to the 4th, which is a power. We're going to raise that up to another power to the second power. So it says for every non-zero number a and integers m and n, the power a to the m raised to the nth power is going to equal to a to the m times n. So in other words, if we have a power being raised to another power, we are going to multiply our exponents. So right here you can see 5 to the 4th squared really becomes 5 to the 4 times 2, or 5 to the 8th. So let's take a look at a few examples to see how this works. For example 1, we want to simplify x to the 3rd raised to the 6th power. So this is going to become x to the 3rd times 6, because I have a power raised to a power, which you can see right here. That tells me I have to multiply my exponents, and I end up with x to the 18th. Likewise, for the next part, I have a to the 4th raised to the 7th. So again, we have a power to a power, so I multiply my exponents. So I end up with a to the 4 times 7, or a to the 28th. And finally, we have a to the negative 4th raised to the 7th. Again, we have that power to a power. So I have a to the negative 4th times 7, which becomes a to the negative 28th. Now I do have to keep in mind the rule about negative exponents. So that negative exponent tells me that I'm in the wrong spot and that we need to move that down to the denominator. So this is going to simplify down to 1 divided by a to the 28th power, and this is my final answer. For example 2, we have a little bit more stuff going on here, okay, but we're going to apply the properties of multiplying exponents that we've learned so far. So for this first part, we have c to the 5th times c to the 3rd raised to the negative 2nd power. So if you recall, based on order of operations, we have parentheses, exponents, multiplication, division, addition, and subtraction. So with this first problem here, we have to abide by the exponent first, then we're going to do our multiplication, which would be second. So that tells me I need to look at this part first because I have my power to a power, then I'm going to worry about my multiplication. So I really have c to the 5th times c to the, and then because I have a power to a power, this is really going to be 3 times a negative 2, or I end up with c to the 5th times c to the negative 6th. Now I can focus on the multiplication where I have a same base being raised to an exponent. So if you remember, when I have the same bases and they're being multiplied, I'm going to add my exponents. So this here is going to give me c to the 5th plus a negative 6, which is c to the negative 1st. And then, of course, I have to take care of that negative exponent, which is going to give me 1 divided by c to the 1st. And this here then would be my final answer. For this next part, I have something similar. I have t squared times 7, or t to the 7th raised to the negative 2nd. So again, I need to focus on that exponent piece first, which is right here. So I have t squared times t to the 7 times a negative 2. So I have t squared times t to the negative 14th. Now I have the same bases being multiplied, so I'm going to add my exponents now. So this gives me t to the 2 plus a negative 14 is really t to the negative 12th. And again, I've got to simplify that negative exponent. because it's negative in the numerator, that tells me that that really belongs in the denominator. So I end up with 1 divided by t to the 12th power, and that's my final answer. Now for the last part, I have a to the 4th, and we're going to square that. Then I'm going to multiply that by a squared to the 5th power. So I'm going to take this one part at a time. So a to the 4th squared is really a to the 8th power. I have to go, this is really 4 times 2. And then I'm going to multiply that by a to the 10th, because this is really 2 times 5. And now because I have two powers that are being multiplied by each other with the same base, I'm going to add their exponents. So this becomes a to the 8 plus 10, or a to the 18th power. The next thing we have is what we call a product to a power. And what a product to the power is this is, you typically are going to have parentheses, and this is kind of like a distribution type thing. So right here you can see that we have 3 times x inside of parentheses, and the whole thing is being raised to the 4th power. So essentially, as I just mentioned, we are going to distribute that power onto both of those numbers. So it becomes 3 to the 4th times x to the 4th. 3 to the 4th will simplify down to 81, and x to the 4th is just going to stay x to the 4th. Again, this is what we call a product to a power, and it says for every non-zero number a and b and integer n, the product of ab raised to the nth power can be simplified as a to the nth times b to the nth. Let's look at a few examples and see how this one's going to work. So for example 3, it says to simplify x to the negative 2nd squared, and then we're going to multiply that by 3xy squared to the 4th. So this first piece here, this should look pretty familiar, kind of like what we did in the last section. This here is a power being raised to a power. So this is going to give me 3x. Remember, powers to powers mean that we have to multiply. So I have negative 2 times 2 will give me a negative 4. And then this is where we just learned this new rule. Now I have a product being raised to another power, because this is 3 times x times y squared raised to the 4th power. So now I have to distribute that 4 onto all 3 of these. So I end up with 3 to the 4th times x to the 4th times y, and then we're going to treat this as a power to a power. So y squared raised to the 4th is really y to the 8th. So now when I simplify these, I'm going to bring my constant or my number out. So I have 3 to the 4th. I can collect my x to the negative 4th and multiply that by x to the positive 4th. So that's really x to the negative 4 plus 4, which is going to be to the 0. And then I'm left with y to the 8th. So now when I take it to my final step, I have 3 to the 4th, which is 81. Anything raised to the power of 0 is always 1. So this is going to give me 81y to the 8th. Now for the second problem here, I have c squared raised to the 3rd power. So this is going to give me a power to a power, which means I'm going to multiply my exponents of 2 and 3. So this is c to the 6th times. Here I have a product being raised to a power, so I do have to distribute that power. So this is going to be 3 to the 4th power times c to the 5th raised to the 4th is a power to a power, so now I have c to the 20th. And when I go ahead and simplify this, I'm going to pull my constant out front, which is 3 to the 4th. Then I have c to the 6th times c to the 20th. This is going to give me c to the 6 plus 20, or c to the 26th. And I can simplify this because I know that 3 to the 4th is really 81. So I end up with 81c to the 20th. Now for the last part of example 3, I can see right away I have products in both sets of parentheses raised to powers. So that tells me I am going to have to distribute. So this is going to give me 2 to the 5th times a, and here I have a power to a power, so this is a to the 3 times 5, which is 15, And then I'm going to have to do the same thing over on the other set of parentheses. I'm going to have 3 to the third times a to the third, because I'm going to have to distribute that here. And then I have b squared raised to the third, so I end up with times b to the sixth. Now I'm going to go ahead and simplify. So here I have 2 to the fifth, which is 32, times a to the 15th, times 3 to the third. Well, 3 to the third is actually going to give me 27. So I end up with times 27, and then I have a cubed and b to the sixth. Now I can do one more step to simplify. I have 32 times 27, which is going to give me 864. I have a to the 15th times a to the third. So I have the same bases. That means I'm going to add the exponents. So that's going to give me a to the 18th. And then my b to the 6th is just going to remain the same. So this here is my final answer. And for the last part to this problem, again, I have a product being raised to a power and another product. So I'm going to distribute. So this gives me 6 cubed times m to the third times n to the third. Then I'm going to multiply that by 5 squared. And then that's going to be multiplied by m to the power to a power. I'm going to multiply, so m to the negative 6. And again, I'm going to simplify. So 6 cubed is going to give me 216. M cubed, n cubed, times 25 m to the negative 6. I'm going to multiply my 216 by 25, and I get 5,184. My m cubed times my m to the negative 6. Same base means I'm going to add. So 3 plus a negative 6 is a negative 3. And then I'm just going to carry that n down to the end, so I get n cubed. Now when I look at this, I do have one little issue, and that is the fact that I have a negative exponent. So my m term is going to have to get bumped to the denominator. So I have 5,184 n to the third divided by m to the third. And this here will be my final answer. Please let me know if you have any questions. Otherwise, I hope you guys have a great day, and I will see you in class.